What's up you guys, and welcome back to the channel. We'll be continuing from where we left off in the last video, which was on the Liskov substitution principle, and in today's one we'll be doing the interface segregation principle. This one is quite similar to the single responsibility principle in that if you kind of get that one, you will most likely get this one as well. So to start off with, the definition I found on Wikipedia for this principle is no client should be forced to depend on methods it does not use. Or another definition for this is, or the one that I prefer, is an interface should describe one set of behaviors. So I mean, yeah, like both are quite similar. However, the last one focuses mainly on, or the key word in the last one is interface. So like with classes in the single responsibility principle, where the rule is a class should only do what it set out to do and nothing more than that, the same is applied for when creating an interface. So when we describe behaviors in an interface, we shouldn't add any behaviors that don't need to be applied to that interface. So yeah, we'll be doing this in Python, just like the last few videos. The thing to point out though is in Python we don't have like a, I guess, formal way of creating an interface, whereas with like Java or C++ or even Golang, like you do have that kind of functionality there where you can create an interface. In Python it's more of an informal way. We could go about using the ABC library that's built in with Python, like use the ABC meta as meta class when creating a Python class. However, in this one we're going to do it in quite an informal way, in that like the behaviors that we describe in our interface or interface, they're not strictly enforced, like whereas in Java if you were to create it, they are strictly enforced. And I guess, yeah, that's can be seen as a downside with Python, but we can apply this rule here as well. So you can probably tell that like I've changed my theme on my VS Code. I'm definitely a sucker for that. I guess every few days I change it to something else. This one, however, is I really like this theme. I think it's called the if you are curious, the Noctis High Contrast. It's a really nice one. And also I think, yeah, readability wise, like it might be easier for you to see this. Yeah, like when looking at the videos afterwards, like it was like, yeah, maybe I should pick a different theme. So I guess for this one, we'll stick with this. So for this one, we're going to work on, like the example we're going to use is that of a coffee machine. So we'll create class coffee machine like so, and we'll implement a few methods like make latte, and we'll raise a not implemented error. So we'll use this as like our interface, and we can do, actually let me just point this out, our informal, or I guess just interface, and we can also create make espresso and raise not implemented error there, and we can also do make cappuccino. I hope that's how it's spelled. Actually, let me check. Cappuccino, yeah. Okay, cool. So raise not implemented error. Yeah, so coffee machine being our interface. I guess we could like use the abstract method maybe later. But yeah, so or the abstract decorator, sorry. But yeah, this is our interface, and now we can create a cool coffee machine, and this will inherit from, or make use of the interface coffee machine, and we can implement make latte, like so, and print making a latte. And we can do make espresso, miss the O, make espresso, and print making espresso. And finally the make cappuccino, making cappuccino. Nice, so that works fine. Just to test it, we can do cool coffee machine and make feeling a latte. So now if we run that, we do Python 3 interface, and making latte, everything's working smoothly. This is all fine. But now let's say we want to create just an espresso machine, so just a coffee machine that only makes espresso. We can do class espresso machine, and that comes from that. We'll use the coffee machine interface, and we can do make espresso. Oops. Like that. Print making espresso. There we go. So now we can run that and do espresso machine make espresso and do that, and we're getting making latte from the cool coffee machine and making espresso from just espresso machine. So that's fine. Like looking at this in, I guess I can doing a quick take on this. This looks fine. Like our espresso machine works. Like we can make an espresso. However, like let's say you're working in like a big team, or you have like multiple scripts. Then if you were to, I guess, let's say you've created the espresso machine, like you made it like 30 days ago or a few days ago, and you kind of forgotten like how it's meant to work, like what comes with this espresso machine. And so you did espresso machine and then the dot, and you'll see that like we've got, we can make espresso, but we can also make latte, and we can make cappuccino, which doesn't make sense for an espresso machine. So if we ran that, we'd also get an error. So if we did that, we'd get the not implemented error. What we could do is just do make cappuccino and then just say pass. If we run this now, like it's fine. Let's just clear that to make it easier. So so we've to fix that, like raise that not implemented error, we've just added the make cappuccino and then passed it. And so if we did that now, like it works fine. However, it's still confusing though, because we still see the dot make cappuccino and make latte. So this is what the interface segregation principle wants you to avoid. So here we're breaking it in that the interface isn't describing one set of behavior. We've got 3 different behaviors where the coffee machine can make a latte, can make an espresso, and make a cappuccino. And that's where we land in this kind of sticky mess with make cappuccino, make latte for an espresso machine. Now, the workaround for this is to instead of using the coffee machine, we turn latte, espresso, and cappuccino into their own interface. So what we could do is, so just below the coffee machine, we can do class latte. Let's do latte machine. and not self, just like this, and we can do make. You can just make latte here, copy that, and actually, yeah, we can let's use a decorator. Abstract method, so we can use this and just do abstract method here, like so. So we've got the latte machine, and then we can also create the other two. So the espresso machine, and this does make espresso, and finally cappuccino machine make. Let me just copy that. Yep, so now we've created three like interfaces, and yep, now it's abiding by this rule. An interface should describe one set of behavior and our behaviors, and in this case our behaviors for the latte machine is just one, which is make latte, and the cappuccino machine just makes cappuccino, and espresso just makes espresso. We could add extra functionality. Let's say for the cappuccino machine, we can do what comes with cappuccino. Let's say add whipped cream, and do that there. Like that. So yeah, we can like add extra behaviors here, or describe extra behaviors here. But so now instead of, so like with the coffee machine or the cool coffee machine, we have make latte, make espresso, and make cappuccino. So instead of we could keep the coffee machine here, and that could like inherit or make use of these three, like I guess, main functions of a standard coffee machine. But in this case, we can just put latte machine, espresso machine, and cappuccino machine, like that. So if we run this now, let's just get rid of this line. It still works fine. So the cool coffee machine has once these behaviors where it can create the latte machine, it can create a latte, an espresso, and a cappuccino. Whereas with the espresso machine, we just want the espresso machine. So we don't need make cappuccino anymore. If we run this, it works fine. And if we were now to do espresso machine dot, and now we don't have like the make latte or make cappuccino, we just have make espresso and all these other built-in functions that come with this class. So yeah, that's really it. Like we've that's the interface segregation principle, and so just to kind of reiterate again, something like this doesn't work out because in our case, like with the cool coffee machine, it was fine, but with the espresso machine, it wasn't a good idea. Like I guess naming here could be better. We could probably call this espresso interface, like that. I don't know if that's a good naming convention in Python, but for this, like just to make this a bit more clear, we can instead just do latte interface, espresso interface, and cappuccino interface, and finally espresso interface. Yeah, that's really it, aside from that little naming error. But this basically works fine now. Like we're aligning ourselves with the interface segregation principle, in that the client, so in the case of the espresso machine being the client, is not forced to depend on methods it doesn't need anymore, so it doesn't need these two methods. I just want to say, sorry for if I repeat myself quite a bit there. This sort of thing kind of needs a bit of repetition to not so much understand it, but to really solidify this into your head. Or at least for me, that was the case. Repetition, I guess, is the best, especially for the design principles. It's a fairly straightforward principle. I hope to you, at least, like the description I gave helped. And as you can see, it's quite similar to the single responsibility principle. The code for this, again, will be on the GitHub repo. I'll put the GitHub repo in the description. Feel free to check that out. And I hope to see you in the next video where we'll just wrap up the solid design principles in Python.